These are the prizes of my collection. Spencer Turbine central vacuums from 1911, 1913, and 1914. It has taken years of searching and quite a bit of backstrain to get these and make them functional again. I love the history of the Spencer Turbine Company, and in my basement I have a wall display of their vintage advertisements. The earliest, from 1910, shows a machine whose design predates my 1911 model with its side-arm dirt container. The square sections in the middle and lower parts of the unit contain trays, which could be pulled out to empty. Here is a period photograph of a larger model installed in the Hotel Taft in New Haven, Connecticut. For years, I have had several modern photographs of a machine of this style saved on my computer, but I failed to document where I had found them. Fortunately, Google Lens helped me out, revealing that this machine is installed in the Ferguson House in Lincoln, Nebraska, constructed from 1909 to 1911. It's a Model 18, serial number 431. If it was installed mid-construction, as most systems were and are, then it's most likely from 1910. Who could hope to ever find a Spencer turbine that old, I thought. Then one day late last year, I was browsing Facebook Marketplace and came across a listing for an antique central vacuum for sale in New Jersey and this picture. I contacted the seller expressing my interest and asking for more pictures. He obliged, and what he sent further convinced me that I had to have this. The badge shows that it is a Model 17, serial number 368, older than the very oldest one heretofore documented. Other pictures he sent show the intake pipe and a very dry-rotted rubber hose, a close-up shot of a very dirty and grimy motor commutator, the exhaust pipe which led into the chimney, the original fuse box closed, then open, with a rope tied around the handle of the knife switch. Somebody was trying to be well clear of this unit the last time they ran it. The unit was located in a New Jersey suburb just over the state line from Philadelphia. My good friend and fellow vacuum collector Evan in Pittsburgh offered his assistance, so we made the drive together from Pittsburgh through Philadelphia into the town of Merchantville, New Jersey. Upon arriving to the large historic home, we were led into the basement and saw the machine for the first time in person. We also took note of a wall inlet near the bottom of the basement stairs. Here I am in my happy place, my smile belying the fact that we were now faced with dismantling and removing this machine weighing many hundreds of pounds, loosening bolts that had been in place for well over a century, trying to keep track of the pieces so everything could be put back together the same way. Here's Evan getting the unit out of its corner after detaching the pipes, in preparation for strapping it on an appliance dolly. We soon realized that even with two of us, one who does CrossFit and the other who is good at talking friends into things, there was no way we were getting this thing up the stairs. Commence disassembly. This is the guard screen around the motor shaft coupling, and here's Evan lifting up the 1 horsepower Wagner motor that weighs almost as much as I do. I don't have pictures of the next part, but even after removing 200 plus pounds from the machine, we still just barely got the lower section containing all the impellers up the cellar steps and out. In fact, we broke one of the steps in the process. Oopsie daisy. I think we fixed that before we left, at least I hope we did. The hard part over, we noticed some interesting things about the installation. Here's where the exhaust pipe entered the chimney. All this buildup surely would have not been good for airflow. In fact, several other systems I have removed have had a similar blockage where the exhaust pipe terminated, no doubt caused by decades of chimney debris building up and solidifying without regular use to blow it out. Also, looking at the Y-junction above the machine where the main lines came together, I noticed the fittings used appeared to be steam or water type fittings rather than the proper recessed hub drainage fittings. Sure enough, that Y fitting was jammed solid with dirt and debris. Here's the junction where the riser pipe from the inlets on the left side of the house comes down and meets with a drop for a basement inlet, though it had a cap in place of the inlet valve, oddly, and continues toward the machine. On the other side of the basement, the riser for the inlets on the right half of the house had been used to run electrical wire to the second floor. Here's one of the second floor inlets, and this picture is looking inside of a plumbing access door adjacent to that inlet, where you can see the hole made in the vacuum pipe to bring the electrical wire out. Also inside this access door, the junction box can be seen where the switch above this inlet connects to the vacuum control circuit. This next shot shows something odd. The left half of the second floor had two inlets adjacent to one another, one in a bedroom and one in a closet for that bedroom. I have no idea why this would have been done. One thing that was very interesting to see was the presence of a newer central vacuum hose. The original Spencer hose and tools were long gone, but this hose, a generic 1970s beige crush-proof hose, suggests that the system was in use well into its seventh decade. This house was full of all types of vintage coolness, like this electrical outlet in the kitchen that had a switch and indicator lamp. The plate appears to have been modified to accept a more modern inlet style, or outlet style rather, and it appears that it originally would have had a type of very early electrical outlet known as a Chapman. The laundry room contained a similar outlet plate with a switch and indicator, but this one had been modified with a duplex outlet. I believe these outlets were used for heating appliances such as clothes irons, and the indicator showed when they were live so you didn't forget to turn them off. Many early appliances did not have their own power switch. In fact, having a home in 1908 wired with electricity to begin with was quite a luxury, and most electrical installations at the time were for lighting only, forcing one to remove the light bulb in a room to screw in the plug of an appliance. A house with electrical outlets separate from the lights was surely deluxe. I also spotted this in a basement workshop area, two duplex outlets with a turn-style switch controlling them. I love weird old electrical stuff like this, as you can probably tell. This house also had two dumbwaiters, the first in the same room as the central vacuum made by the Energy Elevator Company of Philadelphia, the second smaller one in the laundry room. I believe this one was still functional. The first one was floored over above it, and I'm not sure what its original purpose would have been. Having finished our work, we headed back home, stopping in Philly for a cheesesteak sandwich, of course. Here is the machine still in pieces after unloading it in my garage. As I began to reassemble it, I took a couple more pictures of the area below the motor where the air enters, showing the guard screen around the shaft and impeller intake, and showing the trays in place where the sweepings were deposited. Here's a shot of the very dirty motor commutator, and another after cleaning. Those motor windings look to me like the legs of a big black spider. Here's a shot of the motor tag. Wagner, like Century, which also supplied some of Spencer's single-phase motors, was a St. Louis company, and this is a unique motor made for vertical installation. It needed new brushes, among other things, and what better way to measure the brush dimensions than with a promotional Spencer ruler? With the machine assembled and having fitted new brushes, I was eager to test it out. Using a variac, I slowly increased the voltage, but I realized that around halfway to full power, the machine vibrated alarmingly. This concern prompted me to disassemble the impellers in search of the cause. Here is the shaft after removing all 16 impellers, and here they are reinstalled without the deflectors. All seemed well to this point, with nothing loose or damaged. I thought this would be a good opportunity to figure out just how much this unit weighed, so I put each section on the scale individually. The impellers and deflectors weigh 186 pounds. The motor and the upper dirt separator weigh 207. The lower separator weighs 99, and the lower bearing housing and shaft weigh 71, giving the entire machine a weight of 563 pounds. In other words, if it was a person, Dr. Now would be telling it to lose 30 pounds this month. Cleaning and reassembling the machine once again, I was disappointed to witness that the vibration was still excessive. I took a short video from underneath the lower bearing with the cover removed, which didn't show much besides grease dripping on my phone. Here is another short clip of the motor running uncoupled. It sounds pretty good for 115 years old, but I'm still going to treat it to new bearings just in case that helps the issue. In this shot, you can see the centrifugal weights that fly out when the motor is up to speed, lifting the brushes off the commutator and shorting the segments as the motor goes from repulsion start to induction run mode. Now reassembled with new bearings, you can hear how much quieter the motor is. Unfortunately, though the motor was quiet and running happily, when I reattached the motor to the impeller shaft, the vibration remained a problem. I then concluded that the impellers must need to be dynamically balanced, a process which I am not equipped to do. I tore down the machine once again, then reassembled the impellers on the shaft in their proper positions. To safely and easily transport the impeller assembly to the electric motor shop, I put together a wooden cart using letter stencils and spray paint to brand the cart for fun. No copyright infringement intended. Several weeks and a fair chunk of change later, I picked up my impeller cart, which now had its payload spray painted black with washers pop riveted in several spots and a balancing report taped on the side. Now it should be fixed, I said. I took the impellers off the shaft and then set about reassembling all the parts back into the machine. I was getting pretty good at it by this point. Upon my first test of the now balanced impellers, I was quite disappointed to witness the same vibration as before, which caused this 500+ pound machine to walk across the floor before it was even up to full speed. Feeling defeated, I contemplated what to do next. If the impellers are balanced and the motor runs quietly and smoothly, what could be the issue? I seem to recall a reference being made in a historical publication about the vibration produced by vertical fan-type central vacuum cleaners. I thumbed through my copy of Vacuum Cleaning Systems, first noting the response of other manufacturers who called the original Spencer design a tin machine, then observing the line drawing of a machine like mine, which the author refers to as the later type Spencer unit. Finally, on the next page, the author notes that these machines produced considerable vibration, and care must be taken in mounting, with the usual method being to place the machine on a felt pad of considerable thickness. Having saved the filthy but still intact felt pad that this machine sat on for over a century, I tilted the unit and slid it back under. I also noted that there were 4 mounting holes in the base, and though they had not been used in the original installation, I decided to drill through these into my concrete garage floor and place small anchors and screws in these holes. Cautiously, I flipped the switch once again, still quite afraid that my machine might destroy itself from vibration. Ready to cut the power at any moment, I was quite pleasantly surprised to see that the machine came up to full speed and then ran smoothly. At last I could say that this thing was working again, with excellent suction and airflow, performing far better than any other similarly sized system available at the time, even in this relatively primitive design state. While the suction and airflow produced by this machine are excellent, the debris capture method seems almost laughable by modern standards. One must keep in mind that when this machine was designed, the Spencer Turbine Cleaner Company had only been incorporated for a year, and this period of time was literally the dawn of vacuum cleaning itself. Also, at this time, it was expected that someone would go down and empty the sweepings every time the system was used, most likely burning them in the furnace or incinerator. One big surprise was the original instruction sheet, framed and mounted inside a closet off the second floor hallway, no doubt where the hose and tool set once lived. How amazing that not only was it displayed in this way for easy reference by the user of the system, but that it remained there for over a century. Though I am overjoyed to have this, and would have been greatly disappointed to leave the house without it had the owner been unwilling to let it go, it still feels a little weird to remove parts of a historic house like this. I have to remind myself that at least I'm preserving them and sharing the story, instead of letting them be scrapped, as so many already have been. I was given permission to remove the wall inlets, but out of the 8 total in the home, I was only able to get 2 loosened without feeling like I was going to destroy them. It's amazing how similar these very early Spencer wall inlets are to modern Spencer inlets still in production, and a new Spencer hose fits these 116-year-old connections perfectly. So now this 1908 Spencer turbine stands with its younger siblings, all in working order, some of the earliest examples of central vacuum systems in existence, and even at their age, more powerful, more hygienic, and certainly more durable than many of today's vacuum cleaners.